how many degrees go all the way around a circle? 360 degrees, right? So if I know that 360 degrees goes all the way around the circle, if I look at a specific arc, then I'm looking for a sliver of that 360 degrees, so just a section of it. That's going to be an arc. So arcs are just sections of the exterior of the circle. So when we talk about arcs, we need to talk about what's called the central angle. So let's write this down in our definition. A central angle is an angle whose vertex is the center. So is the center. We're supposed to pick one up. Of the circle. So a central angle is an angle whose vertex is the center of the circle. So if we look at this circle here, go ahead and put a dot where you think the center would be, as best as you can.
What was the central angle again?
It's an angle whose vertex is the center of the angle, or center of the circle. So if you create a central angle, right there I just made a central angle, and your central angle is going to create something that's called either a minor arc or a major arc. Okay? So from here to here would be considered a minor arc. Notice how this, call it an intercepted arc. So this angle intercepts the circle and creates just this arc. So from here to here is going to be called a minor arc. The rest of the circle, so everything all around, is going to be called a major arc. Okay. What should be true about the minor arc and the major arc? They should add how many degrees? 360. Good. So if I know a major arc, I could easily get the minor arc by subtracting it from 360. If I know the minor arc, I could easily get the major arc by subtracting it from 360 degrees. Okay? All right, so let's do a semicircle. You've heard of a semicircle before, hopefully. How many degrees is in a semicircle? 180, right? So our actual definition of a semicircle is going to be an arc with endpoints that are the endpoints of a diameter. So remember, a diameter pretty much cuts a circle in half because it goes through the center. So if you have an arc whose endpoints are a diameter, then we know that it has to be a semicircle. All right. Everybody good? Okay, so this is already written for you guys, so we're just going to do an example here. It says the measure of a minor arc is defined to be the measure of its central angle. So go ahead and make a central angle, and we're going to pretend that it is 70 degrees. Excuse me. I'm going to label my endpoints of the arc to be A and B. So this is going to be our notation. Just like when we were talking about the measure of an angle, I'm going to say that the measure of arc AB, so the measure of arc AB is going to be equal to the measure of its central angle. So if its central angle is 70 degrees, then the arc will also be 70 degrees. So the measure of arc AB is going to be 70 degrees. Simple as that. So if the minor arc is 70 degrees, what would be the major arc? So let's recreate that same diagram. Make your central angle. Make an angle that looks to be about 70 degrees. Let's label it AB again. So if I said arc AB, that would still be discussing this arc here. So I need to come up with a new name for the major arc, which goes all the way around. And in order to come up with a new name, I need to add another point. So let's put point C somewhere over there. Looks a little bit like Pac-Man, huh? So arc ACB would be my major arc. So the measure of arc ACB would be equal to what? Yeah, how did we get that?
You just subtract 70 from 60.
Right, so 360 minus 70 gets us to the 290 degrees. Okay, so minor, major, a semicircle would be how many degrees? We already said it. 180 degrees. Good. All right, flip on to the back. So let's see if we've got this. So it's telling us that AB is a diameter. It goes through the center. I want to find the measure of the following arcs. So arc DB would be how many degrees? Good, 135 degrees. Part B, we're looking for the measure of arc DAB. So that means I'm going to start at D, loop through A, end at B. How many degrees would that be? Tell me the thought process that's going on in your head. What are you doing right now? Right, so if this area, or this arc, is everything but this arc, if I do 360 minus 135, so 225 degrees would be the arc DAB. Okay. Really quickly, just to make a quick side note, in part A, when it said find the arc of DB, you always go the shortest distance. If you're given just two letters, go the shortest distance between the two. Don't loop all the way around to get from D to B. Does that make sense? So always go the shortest distance. Unless it gives you 3, then start at the first, then loop through the middle and end at the last. All right, so ADB, so we're starting at A, going through D, ending at B would be how many degrees? Yeah, so 180 degrees, because A and B are endpoints of a diameter, so that makes it a semicircle, or half a circle. All right, so now arc addition. I won't even worry about making the diagram, just fill in the blank here. It says arc addition postulate, the measure of an arc formed by two congruent arcs is the sum of the measures of the two arcs. Which is kind of like a no-duh thing, so don't even worry about the diagram. So if we look at this example, we're going to fill in everything we have. So if I'm given a diagram like this, the first thing I always like to do is fill in anything that's not known. I know that this central angle is 120 degrees, this central angle is 80, and this central angle is 60, but I don't know this central angle. How can we find it? All of them should add up to 360. Okay, so let's do some mental math. 120 plus 80 is 200. 200 plus 60 is 260, so what's left over? 100. So that's 100 degrees. Perfect. All right, now let's read the directions. It says, identify the arc as major, minor, or a semicircle, and then find the measure of the arc. Okay, so for part A, TQ. So I'm starting at T, going the shortest distance to Q. How many degrees would that be? 120 degrees. Would that be a minor, major, or a semicircle? It is a minor arc. What's the number that I'm really looking for to be under for it to be minor?
180.
180. So anything less than 180 is going to be minor.
What if it is 180?
If it is 180, then it's a semicircle.
Oh, okay.
If it's more than 180, then it's going to be major, right? All right, so now let's do part B. Q, so starting at Q, going through R, ending at T. So we could either take 60 plus 180 plus, or sorry, 60 plus 80 plus 100, or if I could talk right, 60 plus 100 plus 80, there we go. Or I could do 360 minus the 120, which both get me to what answer? Yeah, so this would be 240 degrees. Major, minor, or semi? Major, good. All right, C, Q to S. So I'm going to go the shortest distance from Q to S, which would be right here. How many degrees would that be? 160, major, minor, or semi? Good. TS. So the shortest distance from T to S will be how many degrees? 80. Major, minor, or semi? Minor. Good. All right. E. E is T. So starting at T, going through Q, ending at R would be how many degrees? 180. Major, minor, or semicircle? Semicircle. And then starting at R, going through S, ending at T would be same thing, 180 degrees, semicircle. Questions with any of that? Good. All right, and the last thing we have in this section is congruent circles and arcs. So if two circles are congruent circles, if they have the same measure, so now let's think about this. What are the different types of measures we have within a circle? What things can we measure within a circle? Diameter and radius. Good. So in order for me to have two circles that are congruent, meaning they're exactly the same, what would need to be true? Wouldn't your radii need to be congruent with each other? So for these to be congruent, what needs to be the same? The radii. Because ultimately your radii are the same thing as doubling your diameter to get your diameter. So if two circles are congruent, they have the same measure, which is really what we're talking about, is congruent radii. Two arcs are congruent arcs if they have the same measure, and the arcs of the same circle, or congruent circles. So we're looking for congruent radii, we're looking for congruent degrees. We look at the first example here. Are my radii of these two angles the same? Yeah, because they're from the same circle, so they're all going to be the same. Are my central angles the same? Yes. So is arc B, AB, and arc DC congruent? Yes. So we're going to say yes. We could also say, make it fancy, arc AB is congruent to, bless you, arc CD. Okay. Look at the middle one. Do you have congruent circles? Are your radii congruent? Yes. Are your central angles congruent? Yes. So the two arcs created are going to be congruent. So I would say yes. Arc PQ is congruent to arc RS. And the last one, do we have congruent circles? Those circles look the same? No, definitely not. One's smaller than the other one, so no. So one of the arcs are congruent or not? Nope, not congruent. Or I guess say not congruent if we want our proper English. All right, so once you have that, grab yourself a practice space and let's try these out.